Okay, this is the P2 paper from January 2023. It's question number 5, and this is an algebraic methods question. We've got some work on algebraic fractions. We're going to be using the factor theorem. Let's make a start to it. So it says fx is given by this function here, and what we're asked to do is to show that x minus 3 is a factor will lead to this, which is very straightforward. Let's jump straight in and do it. Part A then, so it says, if x minus 3 is a factor, just explain to the examiner what we're doing, then f3 is going to be equal to 0. So f3 is putting 3 in for x in there. If we do that, we get f3 works out to be 3 cubed plus p plus 3 times 3 squared minus 3 plus q. That will all work out to be equal to 0. So that's 27. 3 squared is 9, so plus 9p plus 27, multiplying out that bracket, minus 3 plus q equals 0. And here we've got 9p plus q, and then taking all the constants over to the other side, minus 51, and that's this first part done. So fantastic. It says, given also that when fx is divided by x plus p, the remainder is 9. Well, that's the remainder theorem then, but very, very similar to the factor theorem. So what we're now saying then is that f of minus p will equal to 9. So let's put that in. We're going to do very similar, minus p cubed then, p plus 3 times minus p squared, well, in other words, p squared, minus p, so that becomes plus p plus q equals minus 9. So tidying all of that up then, that will be minus p cubed here, but this will be plus p cubed plus 3p squared plus p plus q equals, sorry, I think it's 9, not minus 9, apologies there, equals 9 there. The p cubes will cancel, so I'm going to get 3p squared plus p plus q, and bring the 9 over, minus 9 equals 0, and that's what I was trying to do for that second part. Part C then says, hence, can we find the values of p and q? So absolutely we can, we just need to solve those two. So for part C, let's have a look and see what we can do here. Yeah, so if 9p plus q equals minus 51, then q is going to be minus 51 minus 9p. So that's coming from there, and what I'm going to do with that is I'm going to now substitute that into q there. So, oops, let's just do that. So we said, sorry, I've lost it. We said 3p squared plus p plus minus 51 minus 9p. Okay, yeah, we can do that. So 3p squared plus p minus 51 minus 9p minus 9 equals 0. That's going to give me a quadratic. So 3p squared minus 8p minus 60 equals 0. You can factorize this using the AC method. Go back and look at previous videos that I've done on that in the how-to section. But that works out to be 3p plus 3p plus 10, p minus 6 equals 0, which is going to give me p equals minus 10 over 3, or p equals 6. Now always go back and just check. Yeah, look at that. So p has to be greater than 0. So let's get rid of this one. That's not in the range, not a solution. So p equals 6 is going to be my answer. We remember that 9p plus q was minus 51, and we now know that p is equal to 6. So it gives me q working out to be equal to, sub it all in, q works out to be equal to minus 105. Let's go and have a look at the last part, part D. It says, hence find a quadratic expression such that fx is equal to x minus 3 times gx. So what that's basically doing is going back to this part here where we know that x minus 3 is a factor. If x minus 3 is a factor, then basically x cubed plus p plus 3 x squared minus x plus q divided by x minus 3 is going to equal to something, isn't it? If it's a factor, it divides in exactly, and this thing here is going to be, in this case, the quadratic that x minus 3 will multiply by. Okay, I'll explain that again properly because I'll explain it to the examiner. So let's do it in a bit more detail. Let's get rid of that. Let's just tidy that up. Okay, so what are we saying down here for part D? We're saying if fx is equal to x minus 3 times this function gx is going to be a quadratic, then what I'm saying is that gx is going to be fx divided by x minus 3. Oops. That just comes down, doesn't it? So if gx is going to be fx divided by x minus 3, if it's going to be this, then that's all I need to find. And in finding that, I'm just going to do the algebraic long division, aren't I? So gx is going to equal to fx. Now, what was fx? Fx is the x cubed. Now, remember, we know what p and q are now, so that works out to be, that function now is fx. So it's that all divided by x minus 3, and that will give me my gx. So, in effect, I've got to do algebraic long division. I'll go through this process and just explain how the algebraic long division works then. So we say, how many times does x go into x cubed? It goes in x squared times, and so now it's x squared multiplied by all of that here. So if x squared is multiplied by x minus 3, what does that give me? That gives me x cubed minus 3x squared. And then what I need to do now is to subtract this from this. When I subtract them, the x cubeds will go, and I've got 9x squared minus 3x squared, so that means 9x squared plus 3x squared. I tend to write that to show what I'm doing here. So that's going to give me 12x squared. Bring the rest of this down now. So minus x minus 105. And we're now going to just repeat that process. How many times is x going to 12x squared? I'm going to do it a bit quicker from now on though. So it goes in 12x times 12x multiplied by x minus 3 is going to give me 12x squared minus 36x. I'm going to subtract that away just like I did last time. The x squareds will cancel and I'll get minus minus makes a plus there, 35x. Bring the minus 105 down. And then for the third time, this time how many times does x go into 35x? And everything should tidy up here. So it goes in 35 times, which gives me, when I multiply it, 35x minus 105, perfect. When I subtract that away then, I end up with 0 as my remainder, which is what I want. I want it to be a factor. And what we've now managed to do is to find what that function there is, what my gx is. So let's just explain the very last part. Therefore, gx is equal to x squared plus 12x plus 35. And that's the last part of question number 5 done. So yeah, really good question involving lots of the algebraic methods, techniques there. So hopefully that all makes sense to you all.